So the last 2 weeks we've been building up a huge collection of skills which allow us to solve all sorts of trig equations. This week is going to be a wee bit different because we are still focused on solving trig equations, but we're not actually going to learn to solve anything or any new techniques as such. Everything that we are going to be doing is going to be focused purely on kind of applying the techniques that we've learned to slightly different styles of equation. And next week's content will also be on that same idea. So the sort of thing we're talking about this week is something like solve tan squared of x tan squared of x minus 3 equals 0. For 0 is less than or equal to x is less than or equal to 360. And most of the examples we're going to do this week, all very nice ranges, and within reason, they're all going to have single x's. So we're not actually using quite as many skills from last week in this session. However, this is not something we know how to solve yet because we've got a squared there. So this is a little bit like our rearranging lesson last week. We've got to get this into a form that we know how to work with. So the first thing we're going to do is add 3. Tan squared of x equals 3. So tan of x is equal to the square root of 3. Now that is all looking very nice and very straightforward, but there's a hidden detail here that we haven't thought about. And hopefully you've picked this up from one of the starter questions. It could be plus root 3 or it could be minus root 3. Now that detail is super important, really easily forgotten, really easily missed, but it's super important because it's going to increase the number of solutions that we've got. So we've really got 2 equations to solve now using all our skills that we have from the last week or 2. We've got one where we're solving tan of x equals root 3, and one equation where we're solving tan of x equals minus root 3. Both of those options are possible if the square of tan gives us 3. So I'm just going to draw, and I would recommend doing them in parallel like this, having the 2 bits separate and just working through each one as if it was its own question. So we're going to work through this one. So x is going to equal tan to the minus 1 of root 3. And if you're doing a cast method, that's also the relative acute angle. We need a quick tan graph while reminding ourselves of that. And hopefully you're just getting good at sketching these, not detailed, but just quick enough, little sketch, but accurate enough to kind of read values off. So our root 3 is up here, say. There's one of our values. There's the other value. So we're looking at 180 plus whatever this is, which I should have worked out up here, sorry, which is 60 degrees. We've got 180 plus 60 degrees. That one gives us 240 degrees. Equally, if you had used cast, like I'm going to fit that in across here. If you'd use cast, tan is positive here and here. That's 180. This one gives us a relative acute angle, which we got up here. This one is 180 plus the relative acute angle. So we've got our 2 values there and there, all sorted. Now you might have seen when I did my solutions last week, I actually started to put things in color just to keep track of everything. So here, that section is a graph. It's the same as that one. That's just me showing it nicely in color. But the other thing that's more important that I started doing was I started highlighting answers as I went through, because that way when I get to the end, I'm less likely to miss answers that I've calculated. So from this, I have 2 answers, 60 and 240. Over here, we're doing the same process. So x equals tan to the minus 1 of minus root 3. Now it's worth noting if you're doing your cast method, your RAA is actually still just the same. So it's still 60 degrees here. If you're not using cast, you're using the graph, you get minus 60 degrees. Our tan graph this time, well, the difference here is we're at minus root 3. So minus root 3 says there. So we've got a value here and a value here. I should have put in my asymptotes really. So that's clearly going to be 180 minus our 60, because there's our minus 60 values over there. So our 3 matching bits of graph are that one, and that one. So we've got 180 minus 60. And we also have 360 minus 60. So we get 120 degrees, or we get 300 degrees. Equally, if you'd used cast for that, no problem with that. We've got a tan that's negative, so that's either up here or down there. If that's 180, then this is 180 minus the relative acute angle. And this one here is 360, so that is 360 minus the relative acute angle. And we get the same two values that we have there. Now that's our next two answers. I'm just going to highlight those just to make it really clear what I've got. And like you'll soon be doing more regularly, because these questions are getting longer and more complicated, I'm just going to list my answers at the end. So we've got 60 degrees from here, 120, 240, and 300. Don't worry if you don't put them in order. I think it looks nice and neat to have them in order, but certainly not mathematically important at all. So one for you to have a go at. Now I'm going to do the your turn a wee bit differently this week. Here is the question. Pause the video and have a go at it there. Sine squared of x equals 1/9. Try the question, and then I'm just going to show you the answer this week, because otherwise the video would be massively long. So pause, have a go at it, and then I'll show you the answer in a minute and talk through it. Great, so hopefully you paused, you've had a go at your answer here. Now, first step was to rearrange. So first step was to square root both sides, and remember to put your plus minus in. So you get 2 bits, sine of x equals plus root a third, and sine of x equals minus a third. Start solving each of those. So when you solve for sine x equals a third, you get this angle, 19.4712. Using either your graph or your cast, you'll get the other angle being 180. Take away that, which is 160.53. Then solving equal to the minus a third, and doing exactly the same system. Your inverse sine will give you something that's not in the range, but you can calculate these two angles, 180 plus 19.4712 and 360 minus, giving you these two angles. Then our list of answers is down at the bottom there, and I'll move that up just a tiny bit so you can see those more clearly. So hopefully that makes a bit of sense, and you've managed to match that up. If there are any little mistakes, hopefully you can see where maybe it's gone wrong. Layout is critical here, though. The clearer you lay out everything you're doing, the clearer you keep everything, the more likely it is that you don't miss any bits of your calculation and you don't miss any possible answers. So that is example number 1 of the kind of thing we are going to be dealing with. Now, in the next 2 examples on this first task, we are going to be moving in. So this is actually a quadratic, because we've got squared there. We're going to look at 2 other types of quadratics that you can get and that you have to be able to deal with. So that's us for this video, and then we'll have a look at some more examples in the next video.